Okay, this is the last of the final review, and although this isn't really final, it's going to occur in the final week. I'm not going to test as a final on the stuff we've done since we went on home study. Excuse me, but we will have a test on that. So, chapter 14 is the chapter that deals with solutions. And so we have a definition of a solution. A solution is a homogeneous mixture. We had a description of how things dissolve. You have to have either polar molecules and dissolving each other, or you have to have polar molecules dissolving ionic compounds, or you have to have nonpolar dissolving nonpolar. There's an important phrase, like dissolves like. We dealt almost entirely in this chapter with aqueous solutions. So if you have an aqueous solution and you have anything which is ionic, we're going to assume that ionic plus water is going to dissolve. By the way, that is not 100% true. I have ionic compounds that don't dissolve in water. But most of the time they do. And so we're just going to assume that they do, although there's always exceptions to everything. And if we have polar molecules plus water, then those will dissolve. And the way they dissolve is that the positive ends of the water are either attracted to the negative ends of the ionic compound and vice versa, or the water molecule and the polar molecules will attract each other because they both have positive and negative ends. But if we have a nonpolar molecule plus water, that's not going to dissolve. We would say that this is insoluble. Not much in the way of definitions on this test, simply because I'm not going to put definitions on because you can just look those up. But there are a number of important definitions. There's the word a solution is made out of a solute and a solvent. And a solute is what gets dissolved, or if they're mutually dissolvable, if they're miscible, it's the one that is the larger part. The solvent is one, or the smaller part. The solvent is what does the dissolving if it's an ionic, but if it's polar, we would say that that is the larger of the two parts. We also have something called saturated and unsaturated. Saturated means that you have, it's completely full. An ionic compound runs out of water molecules to attach to the ions, and at that point it is saturated. Before that, it's unsaturated. Now, the primary focus of this test is going to be on the different things that we've done in this section in chapter 14. So it will be on molarity and it will be on dilution. So molarity is moles of solute over liters of solution. And the dilution equation is M1 V1 equals M2 V2, or if you would rather, M1 L1, M2 L2. This actually is a more useful equation because you don't have to change it from milliliters. You could leave it in milliliters, but that would be that. So one of the things is, remember that if we start or end with grams, and we're doing a problem that has molarity, the very first thing or the last thing will be convert to moles. So let me just real quickly do a molarity problem. Let's say we had something like this. You need 50 grams of, let's say, calcium chloride. You have a 6.2 molar solution. How many liters or how many milliliters do you need? So when we pour out solution, we're pouring out moles of the solute. Because we started with gram, the first thing we'd do is go 50 grams of calcium chloride. 1 mole of calcium chloride happens to be 111 grams. And so 50 divided by 111 is 0.45 moles. So we have 0.45 moles of calcium chloride is what we want. And what we know now is that we have moles and molarity. We want liters. Molarity is moles over liters. So cross multiplying, molarity times liters is moles, or liters is moles over molarity. And in this case, it would be 0.45 moles divided by 6.2 molar. So 0.45 divided by 6.2, and this ends up being 0.0725, which means that moving the decimal place over 3 places, 72.5 milliliters, because that's what it asks for. The dilution equation gets used this way. We would say, let's say we had 42 milliliters of a 12 molar solution, but we want a 6 molar, or let's say we want a 5 molar solution. Well, the question might be how much water you have to have or how much solution of the other do you need. Let's do this. Let's do 42 milliliters times 12 molar is equal to X, or the second volume, V2, times 5 molar. If we divide by 5 molar, we're going to get 42 times 2.4. We're going to have 100.8. Okay, now let's think about this. We started out with 42 milliliters. We're going to end up here with 100.8 milliliters. If I asked how much solution are you going to need for this by adding water, it'd be 100.8. If I asked how much water do you have to add, that would be 100.8 minus 42, and it would be 58.8 milliliters. So you have to watch what you're doing on those problems, but it's actually a fairly simple equation. That leads us then to acids and bases. And what I've done on the test with acids and bases is that I have included, can you recognize whether something is an acid, a base, or a salt, the Arrhenius definition. So if I give you let's say H2CO3 plus calcium hydroxide, and that gives me calcium carbonate plus water. This is my acid. Why? Because it has a hydrogen with it. This is my base, and this would be my salt. You need to be able to recognize acid, base, and salt. You should be able to, trying to think what else I have on that test. You should be able to recognize when we deal with a Bronsted-Lowry acid or base, which one is the conjugate acid or the base. So if I had, say, what I'm going to do is give something like this, where I give an acid or a base, and I make you choose which one is which. But remember, with Bronsted-Lowry acids and bases, what we would have, in fact, let me do it this way. Let's say we took this is carbonic acid plus water, and that would give me H3O plus HCO3 minus 1. This would be our acid because it's donating a proton. This would be its conjugate base. This would be my base, and this would be the conjugate acid for it. And what you do to figure out what the conjugate base is for an acid is we simply take away one hydrogen. We remove H plus, and that would give me HCO3 with a minus 1. And for the base, if we have H2O, we add one H plus, and that's then going to be H3O plus. So you need to be able to recognize conjugate acids and conjugate bases. And you also need to be able to do a neutralization reaction. And so let me come back to that one that we had. If we had H2CO3 plus calcium hydroxide, and that gave me calcium carbonate plus HOH, I actually don't need this balance to be able to do it. What a neutralization reaction does is it means that we have exactly the same number of OHs and Hs. So when we are neutralized, we have the moles of H plus is equal to the moles of OH minus. So let's say we're told that we have 50 milliliters here of 3 molar. And we want to know, and it turns out, in the way the problem will be worded, it'll say 50 milliliters of 3 molar H2CO3 carbonic acid is neutralized by, let's say, 38 milliliters of calcium hydroxide. And then the question would be is, what is this molarity? And again, that's a technique that gets used in chemistry to figure out if you know exactly what you have here, you can figure out what this would be. So you start adding this into here until it neutralizes, count up exactly what you've got, and you've figured it out. Well, what we can do is that we can take these two, 0.05 milliliters times 3 molar. This is 0.15 moles of H2CO3. But every H2CO3 is going to give us 2 H pluses. And therefore, this will end up being 0.3 moles of H plus. And this is our key. We then need 0.3 moles of OH minus. That's our key. Well, 0.3 moles of OH minus, notice every calcium hydroxide has 2 of these. So if you have 0.3 moles of OH minus, all you need is 0.15 mole of calcium hydroxide. Because for every calcium hydroxide, I get 2 of these. And now we've got it because I now know what my milliliters and my molarity is. And the molarity of calcium hydroxide is going to be 0.15 moles over 0.38, actually 0.038 liters. And this would end up being 0.15 divided by 0.038. And that would be a 3.9 molar, 3.95 molar solution of calcium hydroxide. So I know that was pretty quick to run through that like that, but that's a quick review on the that other test that we'll have on chapter 14 and 15.